Lesson 1.11, Estimating. Estimation is the process of arriving at an approximate answer to a question, and by approximate we mean really close. Estimation by rounding. We can use this in very real-world applications. We can purchase bread, detergent, a sandwich, an apple, and coffee, and when we get rung up, the bill is $18.67, and we can decide rather quickly if this amount seems reasonable or not. First, we round each amount so that we can add very quickly. $2.59 is about $3, so this one rounded up. $2.17 is about $2, we round down. Round up, round down, round up. Those numbers are very easy to add quickly. 6 plus 4 plus 2 plus 3 is 15. And as most of the items rounded up, we can safely say that 1867 was too high and a mistake was made. Another application is to estimate your salary so that you can quickly tell if your paycheck was accurate or not. Let's say a carpenter works full-time at $28 per hour and we want to estimate his weekly salary. First, we want to know how many hours does a full-time person work. Well, a full-time person will work about 40 hours a week. Next, we're going to round the hourly salary. 28 is about 30. Then we'll multiply the hours per week times the hourly salary. Estimation makes multiplication much quicker because I can take that 40 times 30. I multiply 4 times 3 and get 12. And then I count how many zeros there were and put those on the end. So this carpenter is going to make approximately $1,200 per week. Then I can estimate his annual salary. We figure out how many weeks are in a year. Round the number of weeks, and then we multiply 50 times 1,200, and he's going to make approximately $60,000 per year. How we got that is we multiply 5 times 12, which is 60, and then you count how many zeros. 1, 2, 3, 60,000. We can apply estimation techniques to circle graphs or pie charts. We can use a circle to represent the whole and divide it into sectors proportional to their part. That's how a pie chart is made. So here's a representative pie chart. The U.S. Census Bureau said that there were 220,948,915 Americans over the age of 21 in 2008. This pie graph represents how Americans define old age. We have a decline in mental functioning, a decline in physical activity, becoming a grandparent, retiring, unknown, or reaching a specific age. We can determine a calculation that shows the number of Americans that are over 21 and how they define old age, first by a decline in physical activity. So our first step is to identify the percentage of people that believe old age is a decline in physical ability. That would be our 41% right here. We're going to convert the percent to a decimal. Now, we have to convert percents to a decimal before we can multiply them because we can't multiply a percent. We can only multiply a decimal. A good way to remember this is if you write decimal and you write percent alphabetically. To go from a percent to a decimal, you move 2 spaces to the left. To go from a decimal to a percent, you move 2 spaces to the right. It's nice that it worked out that way so that you can quickly remember which direction to move. In this case, we're going to move left, so I'm going to move this decimal place 2 places to the left and get 0.41. Then I would multiply the percent as a decimal times the number of people in the population. This would be my actual calculation. And this calculation is doable, but we can make it easier if we estimate. So first we'd round the decimal. 0.41 is about 0.4. And then we would round the population. 220,945,915 is close to 200 million. Sorry. And then we would multiply that to determine how many people think old age is decline in physical activity. So we'd take that 200 million, that's a 0, and multiply that by 0.4. 2 times 4 is 8. This decimal place is going to take 1 0 off. And I have 1, 2, 3, 4, 5, 6, 7 zeros. So 1, 2, 3, 4, 5, 6, 7 zeros. So about 80,000 people, or sorry, 80 million people would think that old age is a decline in physical activity. We can apply estimation and inductive reasoning to data and bar graphs. Here we have life expectancy by year of birth for both males and females in the United States. So we can estimate a man's increased life expectancy rounded to the nearest hundredth for each future birth year. Now, what we'll do is we'll find this rate of change. That's the increased life expectancy. Okay, so males are blue. Here I have 66.6 and 75.2. These would represent our dependent variable in our rate of change. So I have 75.2 and 66.6. And we're talking about how many years? 45 years. So 2005 minus 1960. Well, now if I want to estimate this, I'm going to round these to 75 minus 67 and 45. 75 minus 67 is 8 divided by 45. 8 divided by 45 is 0.17 repeating, so it's approximately 0.18 per year. So age increases by about 0.8 per year. 0.18 per year. Using that information, we can estimate the life expectancy of a man born in 2020. Now in 1960, it was 66.6. 2020 minus 1960 is going to be how many years? Well, that'll be 60 years. We take that 60 years, we multiply it by our increase per year, and we're going to have an increase of 10.8 years. We add that to our 66.6. And in 2020, a man should live to be about 77.4 years old. We can estimate a woman's increased life expectancy. In 1960, a woman was on average living 73.1 years. And in 2005, 80.4. So we can round these. 80.4 will round to 80. 73.1 will round to 73. Again, I have 45 years. 80 minus 73 is 7. 7 divided by 45 is 0.15 repeating, which is about 0.16. So a woman's life expectancy is increasing by about 0.16 per year. Now we can estimate the life expectancy of a woman born in 2050. We'll take 2050 and we will subtract 1960 from it, just as we had done before. and that'll be 90 years. We'll take our 90 years and we'll multiply it by 0.16, giving us 14.4 years for increase. And then we take our 73.1 in 1960, we add 14.4 to it, and in 2050, the average life expectancy of a woman would be 87.5.